some of you who are new to it, it's going to be pretty confronting because we're going to go over a lot of stuff. And so what I'm going to do, I'm going to talk up here, I'm going to talk fairly slowly, I'm going to try and present it, and then we're going to have a bit of a task that follows this. But probably what you should do is try and either watch and write at the same time, but if you're finding that a bit too challenging to keep up, it's more important that you just listen. Okay, so copying this down isn't so important. What's more important is that you're understanding what I'm talking about. Okay, so I'll just say that again. It's not so important that you copy it and have it on your paper. It's more important that you understand what I'm talking about up here. So what we're doing here, what we're talking about is we're talking about advanced trigonometry, aren't we? And so back in year 9, you know, you're putting in your calculator all the time. You know, you're putting in sine 23, and then you might put in cos 54. And maybe, just maybe, you wondered, what does that actually mean? Like when you, and then you tried to press it. Oh, if I press, what is sine equal? Like if I just press sine, what is that equal to? And maybe you press it and it says math error. And so the answer is, well, the value of sine depends on the angle, and we develop it from what we call the unit circle. So let's go through that and let's explain to you where we get sine, cos, and tan from. Well, we have a circle drawn on the Cartesian plane. Its center is 0, 0, and it has a radius of 1 unit. Okay, so from here to here, the distance is 1 unit. So then we're gonna start with this circle. We're just gonna go around and list all of the coordinates. This is gonna be x is 1, y is 0. All right. If we go to this point here, up here, x is 0, but y is 1. Over here, we've got x is minus 1. And y is 0, and then down here we've got x is 0 and y is minus 1. We've got all of those coordinates at those 4 points of the circle. Okay, then we're going to consider point P, okay, which is a point on the circle, and it has coordinates x, y. We don't know what they are, they could be anything. Okay, we've got point P, coordinates x, y, could be anything. And its position is dictated by theta. So what I'm going to do is I'm going to draw a line here, and this is going to be the angle theta. And so if theta is really small, then point P is going to be down here. If theta is really large, the point P, its position depends on the value of theta. Okay? If theta is 90 degrees, point P would be here. If theta is 180 degrees, point P is going to be here. Okay, if it's 135 degrees, it's going to be halfway, it's going to be here. So this point P, it depends on whatever that value of theta is. Okay, now from here, you might think, oh, look, that's a triangle. So we're going to grab that triangle and we're going to pull it out of the unit circle. And so we've got here a triangle. What is the length here of the hypotenuse? 1 unit. Remember, this circle has a radius of 1 unit. Okay? So wherever that point is, this distance is going to be 1, and so this triangle has a radius of 1. It's a right angled triangle because we've drawn that line straight down. And we've got, this is theta. We've defined that as theta. And this distance here is just going to be the y coordinate, because the distance from there to there, that's from x is 0 to this y value here, is the y coordinate. So whatever the y coordinate is, could be anything between 0 and 1, could be anywhere along there. Whatever the y coordinate is, the height of the triangle is going to be y. And similarly, the distance from here to here is going to be x, because starting at 0, it has an x coordinate, could be some number between 0 and 1, could be 0.5, 0.8, whatever it is, this value here is going to be x. Okay. So that's okay so far. All we've done is drawn the circle, it's got a radius of 1 unit, we've got the triangle, we've pulled it out, and we've got this sort of starting point. So now we're going to go back to what we did in year 9 trig, okay? And we're going to remember SOHCAHTOA. SOHCAHTOA. Okay, so that means sine, the sine ratio is opposite on hypotenuse, cosine is adjacent on hypotenuse, and the tan ratio is the opposite on the adjacent. So let's go through and label our triangle. I'll use some multicolour. So we're going to label the hypotenuse. The hypotenuse is always the longest side, it's always opposite the right angle. The adjacent side connects the right angle and theta. So that's our adjacent side. And then the opposite side, you can say it's either the side that remains or it's opposite the angle that we're given. That's the opposite side. And so we can, now that we've labelled the triangle, we can make some statements about connecting these things that we have here. So firstly, let's say we want to solve for y. All right, if we're trying to solve this unknown, what is this value equal to? We're going to have, we need a ratio that involves O and H, because we've got a value there. We don't know this is unknown, so we're going to ignore it, but we do know this one. We know this, and we're just saying this is some angle, we know this. Okay, so we've got H, and we're trying to find O, H and O. What ratio involves H and O? Sine. Sine involves O and H. And so we're going to make the statement, sine theta equals O on H. O is Y, and H is 1. And Y on 1 is just Y. And so from here, we've got Y equals sine theta. All right, here's sine theta. Sine theta is O on H. O is Y, H is 1. Y on 1 is just Y, so sine theta is Y. Okay? We're going to do the same for the x value. All right? We're going to do the same for the x value. We're going to say, all right, we want to find the x value, and so we're looking for something that involves A and H. Which trig ratio involves A and H?
Cosine.
Cosine. Cos is A and H. So let's make that statement. Cos theta is A on H, which is A corresponds with x, H corresponds with 1, and so we've got x equals cos theta. Okay. This is important because now any coordinate along the outside of this circle, its value is going to be, its x coordinate is going to be cos theta, and its y coordinate is going to be sine theta. And so point P, the coordinates of point P are cos theta, sine theta. Remember, we said the position of P depends on the value of the angle. So P is cos theta, y is going to be sine theta. Okay, let's take it one step further. Let's go, well, what about tan theta? What is tan theta? So we've used sine, we've used cos, what about tan? Well, tan theta is O on A. Tan is O on A. And so if we take O, O is Y, and A is X, so tan theta is Y on X. But Y, in its most simplest form, is sine theta. And X, in its most simplest form, is cos theta. Okay, so we have another definition here. Tan theta is sine theta divided by cos theta. Okay, so what I'm drawing a box around here, these are two identities so far that we've proved that are going to be very important. We've got one more. Okay, from this right angle triangle, okay, if we were to just make the simple statement, we could look at that and go, Pythag, x squared plus y squared equals 1 squared. Okay, but what is x? X is, in its simplest form, cos theta. Y is sine theta. Okay, and so then we have our third identity, which is cos squared theta plus sine squared theta is 1. Now, just a form of notation, all right, here I've written in brackets cos theta squared, okay, that's to show you that's what we're doing. This is the correct way to write that, okay, you write cos, you put the squared, and then you have theta, same with sine, and then the same with tan, okay. So we have 3 important identities that we've derived here just from a sketch of the unit circle and explaining those relationships. Okay. What do you need to take away from this? This is the most important. The value of x, okay, the x coordinate for any point P is going to be cos theta. The y coordinate for any point P is going to be sine theta. Excellent. Okay, so that's on our first page there for 5C. You look at our second page, we've got a blank unit circle, and we're going to go through and fill that in now. Okay, so this is a circle, it's got a radius of 1 unit. So that means probably the first thing that we should put in here, we're trying to fill in all the coordinates and we're trying to fill in all the angles. So let's make sure you got a pen out now and we'll start doing this together. The first thing we can fill in is these coordinates, okay? Because we know that by definition. Circle with a radius of 1 unit, that's what we started with over here. Okay. The next thing we're going to do is we're going to do the multiples. We're going to go through and do the angles. Now, if you look, you've got a number of lines here. One of them's got a degree sign next to it, I believe. And so that is the halfway point. That's going to be 45 degrees. Okay? And then we're just going up by multiples of 45. So if that's 45, this one here is going to be 90. We're going to skip these ones in between for the time being. This one's 90. And then the next one that's halfway between 90 and 180, okay, is going to be 90 plus 45. Okay, it's halfway between 90 and 180. Halfway between 90 and 180, we're adding 45. That's going to be 135. Okay, so I'll stop there. I'll let you guys carry on this pattern, just adding in the 45. So I'll give you a minute to do that. So we've got 180. We're going. The next one that's halfway is 180 plus 45. Okay, so we should have, 225 and 270 and 45, 315. Okay? And we still have 8 spots to fill in. Okay, so what we've done is we've done the multiples of 45, 90, 135, 180, 225, 270, 315. And here you've got 2 values for degrees. You've got 0 degrees and you've got 360 degrees. Okay, so if you've gone the whole way, 360 degrees if you're just starting out there at 0 degrees. Then we're going to go around in multiples of 30 degrees. Okay, so the first point here is 30 degrees. All right, and then you go, well, what's 30 degrees plus 30 degrees? This point's going to be 60. Then you've got 90, and then plus another 30. You're going to have 120. 120 plus 30, 150. Okay, so keep going around, plotting all those degrees on. You've got multiples of 30. Okay, so I'll fill them in here, 180, 210, 240, 300, and 330. Very good. Okay, now remember I said for any point along the outside of this circle, the coordinates are cos theta, y theta. Okay, so if we've got this angle here is 30 degrees, that's what that line's telling us. Which means the coordinates of this point here are going to be cos 30 and sine 30. Alright? The x coordinate is cos of theta, the y coordinate is sine of theta. What I want you to do is pull your calculator out and let's find the coordinates of this point. And we should get 3 on 2 and a half. Okay, who's getting something different? You can be honest, because that'll be a calculator set. Is anyone not getting root 3 on 2 and positive half? Everyone got root 3 on 2 positive half? Okay, excellent. Okay, that's a good thing.
Oh, no.
So, all right. Thank you, Noel, for your honesty.
1 radians.
That's correct.
Yeah.
So what we'll do, let's go through and just get these coordinates just for this part of the circle. Okay, so let's get what are the coordinates at 45 degrees? What are the coordinates at 60 degrees? Alright, so you put in sine 45, cos 45. Alright, and they've got the same answer, which is interesting. Okay. Let's pause for a moment filling in the circle. Let's explain why that's true. Okay, if we have a right angled triangle, alright, it's a bad scale here. This is 90, this is 45. What is the value of this angle? 45. What kind of triangle is this? Isosceles. Okay, both angles are the same, which means both of these sides are the same value. Alright, and remember up here we've got the x value is the same, the y value is the same. Of course that's true. Okay, because it's an isosceles triangle. Okay, so it's starting to get a little bit messy up here, but I think we're understanding how we're filling in those coordinates. Okay, when we're just doing that with degrees. Okay, let's pause that for a moment. We notice we've got these other blank spots as well, and I've said when we're for this unit, mostly we're going to be dealing with radians. Okay, like 90% of the time we're going to be dealing with radians. So what we're going to do is we're going to pause with the degrees there, and we're going to go around the circle, and we're going to convert every degree unit, every unit that's in degrees, we're going to convert to radians. Okay, so you can flip back at your notes. How do I convert from degrees to radians? Right, and we just follow the arrow. We have to multiply by pi on 180. And you're going to do that for every position around the whole unit circle. Okay, so I want you to do that now. Take about 2 minutes to do that. Find the radians for every single position.
Do you put it as well? Oh, sure. So.
I'm going to rub out a bit here because I think we've got most of that first quadrant. I just want to make a bit more room, make it a bit less messy.
simplest form.
Yeah, that's correct.
Right.
I want to make that point. Yeah.
Oh,
Yeah, you will put it in simplest form.
oh no, okay, I'm doing that good.
Yeah, don't look at what I've done there. I just want to make a point. Okay, so even if you're not finished, I'm going to stop here, and I do want everyone just to look here, because I do want to point out one important, this circle is prolific with patterns, and I want to point out one of the important ones. Okay, the first is that, you know, we have those multiples of 30, 60, 90, 120, okay? Now 30 degrees is pi on 6, and so here you've got one lot of pi on 6 at 30 degrees. At 60 degrees, you've got two lots of pi on 6, okay? Or in its simplest form, you can simplify that fraction, you can divide the top and the bottom by 2, is pi on 3, which is why you've got that value there, 2 pi on 6. Here we've got 3 pi on 6, okay? So look, one lot of pi on 6, two lots of pi on 6, 3 pi on 6 in simplest form, pi on 2, 4 pi on 6, 5 pi on 6, 6 pi on 6, okay? 6 at the top, 6 at the bottom, that's just pi. And it just keeps going. Every multiple of 30 degrees is just another lot of pi on 6. Okay? And so that's an easy way to generate those multiples of pi on 6. The same with 45 degrees. Okay, 45 degrees is pi on 4. If we have two lots of 45, we've got 90 degrees, which is 2 pi on 4, which in simplest terms, we've got 2 at the top, 4 at the bottom, is pi on 2 again. Okay, 2 pi on 4. 3 pi on 4, 4 pi on 4, which is just pi, 5 pi on 4, 6 pi on 4, etc. All right, so they're the patterns there. Okay, what I want us to do now is hopefully we've got the degrees, we've got the radians, and we're ready to fill in the rest of the coordinates. But I want you to do it in radians. Okay, so we need to be proficient at changing our calculator. Here's the instructions. You press Shift, Menu. And then about towards the bottom of your screen, you should say something that says angle. Okay, if you hover over that, you can change it from degrees to radians. Okay, so then when we come around here and we want to know the coordinates of this point here at 4 pi on 6 or 2 pi on 3, we're going to go, the coordinates of this point are cos of 2 pi on 3, sine of 2 pi on 3. And that is what we're going to put in our calculator. Okay, we're changing it to radians, and because we've changed it to radians, our angle input needs to be in radians. And we're going to find the rest of the coordinates on this hidden circle using radians. Okay, so I'll give you about 5 minutes to fill in the rest of the circle.
You just did what I'm doing, didn't you?
Yeah, I didn't do it in radians, I just did it using the pattern that I remembered from last year.
No worries, let's make sure you got it right. Good. 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 Well done.
Remember this?